And now in this lecture, we'll find out the area of the green triangle, triangle ABC. In the drawing, we have quadrilateral AB, PCB. This is the quadrilateral. We know that side AQ equals to side AC. We also know that side AB equals to 5 units in its length. Side CP equals to 4 units in its length. This is angle QPC that is equals to 60 units in its size. This is angle PQC that is a right angle. This is angle ABC that is equals to 60 degrees in its size. Again, our task is to find out the area of this green triangle, triangle ABC. So first of all, we will do a construction, that is to say, from this point A, we will do perpendicular on QC. Again, from point A, we will do perpendicular on QC. Secondly, this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and Q3. This point is point M. We have the rule that says that, first of all, triangle AQC is an associated triangle because side AQ equals to side AC. And QC is the base of the associated triangle, triangle AQC. And we have the rule that says that the perpendicular to the base of an associated triangle bisects the base. So according to the rule that I mentioned, the perpendicular AM to the base QC bisects the base QC. That is to say, QM equals to MC. QM equals to MC. So it bisects side QC, so each half equals to QC over 2. So if we define the first half QM as A, then the second half MC must be also equal to A. In the next step, we will extend the perpendicular AM by a straight line until it touches side PC. And we define the touching point of the extended perpendicular AM with side PC. This point is point N. We will focus on the right triangle, PQC. On the right triangle PQC, 90 degrees plus 60 degrees is equal to 150 degrees. Again, in the right triangle QPC, 90 degrees plus 60 degrees equals to 150 degrees. Again, 90 degrees plus 60 degrees equals to 150 degrees. Therefore, this third missing angle must be equal to 30 degrees in its size, according to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. Therefore, this third missing angle must be equal to 30 degrees in its size. AM is a perpendicular, therefore it is absolutely a straight line. And when you extend a straight line by straight line, the result AN must be also a straight line. So AN is a straight line. So if we focus on the right side of the straight line AN at point M, here the sum of the angles must be equal to 180 degrees according to rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the right side of the straight line AM at point N, which angles we have at the right side of the straight line AN at point M. We have this angle that is right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees in its size. So, in the small right triangle NMC, 30 degrees plus 90 degrees, it is 120 degrees. Therefore, this third missing angle must be equal to 60 degrees in its size. Y equals 60 degrees plus 120 degrees is 180 degrees. That is the sum of the angles in any triangle. Therefore, this missing angle must be equal to 60 degrees in its size. It is very easy to see that the big right angle CQP is similar to the small right angle triangle CNM. So why those two right triangles can are similar to each other? First of all, this is angle C, that is a common angle that belongs to both triangles. Angle C belongs to the small right triangle CNM, and angle C belongs also to the big right triangle CQP. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 60 degrees and therefore they are equal to each other. So if we found out that the big right triangle CQP is similar to the small right triangle NMC according to angle similarity rule. So I write it down. Now we found out that the big right triangle QPC is similar, this is the sign of similar, to the small right triangle NMC according to angle similarity rule. Repeat again. If we found out that the right big triangle APC is similar to the right small triangle MNC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side MC of the right small triangle MNC over side QC of the big right triangle QPC is equal to side side NC of the small right triangle NMC over side PC of the big right triangle QPC. And again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side MC of the small right triangle MNC over side QC of the big right triangle QPC is equal to side NC of the small right triangle MNC over side PC of the big right triangle QPC. MC is A according to our definition over QC. QC in total equals to A plus A, that is 2A, and it is equals to NC. NC is the missing side, so we leave it as it is, over PC. PC equals to 4 units in its length according to what is given as the question. So in total, we should find out that A over 2A equals to NC over 4. So here we have A in the numerator and the A the denominator, so A will get cancelled. After we cancel A, left here only with 1 half. So 1 half equals to MC over 4. Here we cross multiply this equation and we get that 4 equals to NC over 4. So we cross multiply this equation and we get that 4 equals to 2 times NC. 4 equals to 2 times NC. Here we divide this equation by 2 and we get that NC equals to 4 over 2, that is 2. NC equals to 2 units in its length. So this is side NC, that is equals to 2 units in its length. So write it down. NC equals to 2 units in its length. So what is the missing side Pn? Pn equals to PC minus NC. Again, Pn equals to PC minus NC. So I write it down. Pn equals to PC minus NC. So Pn equals to PC, that is 4, minus NC, that is 2. So Pn in total equals to 4 minus 2, that is 2. Pn equals to 2 units in its length. In the next step, we will focus on the big triangle A and B. So I'll copy triangle A and B in a new page and we will analyze this triangle A and B. This is angle A and B, that is equals to 60 degrees in its size. This is angle ABN, that is also equals to 60 degrees in its size. Side AB equals to 5 units in its length, according to what is given as the question. So actually, this is triangle A and B that are coming from the original drawing. 60 degrees plus 60 degrees is 120 degrees, and therefore this missing angle must be equal to 60 degrees in its size, according to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. So 180 degrees plus 60 degrees is equal to 120 degrees. 60 degrees plus 60 degrees is 120 degrees. So 120 degrees plus 60 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Therefore, this missing angle must be equal to 60 degrees in its size. So all the angles of triangle A and B, they are equal to each other, and therefore we actually found out that triangle A and B is an equilateral triangle. So write it down. This is triangle A and B. This is an equilateral triangle. Triangle A and B is an equilateral triangle. And we know that all the sides of an equilateral triangle are equal to each other. That is to say, AB equals to 5, AN therefore must be also equal to 5, and NB must be also equal to 5 units in its length. So we know that NB equals to 5 units in its length. So what is the length of the missing side CB. CB equals to NB minus NC. Again, CB equals to NB minus NC. So write it down. The missing side CB is equal to NB minus NC. Minus NC. So CB equals to NB, that is 5. It is one side of the equilateral triangle AB. Minus NC. We just write down for that NC equals to 2 units in its length. So CB in total equals to 5 minus 2, that is 3. So CB equals to 3 units in its length. This is side CB, that is equals to 3 units in its length. In the next step, from point A, from the vertex A, we will draw perpendicular on CB. Again, from the vertex A, we will draw perpendicular on CB. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and this side CB. This point is point O. We define the length of the perpendicular AO, the length of this perpendicular AO as edge. It's actually the height to the base CB. Why AO is the height of the base CB? Because it creates 90 degrees with the base CB. Therefore, AO is the height to the base CB or triangle ABC. So, in the right triangle AOB, so I copy the right triangle AOB in a new page, and we analyze the triangle, the right triangle AOB. Side AO equals to edge. It is actually the height to the base CB. According to what is given as the equation, AB equals to 5 units in its length. And this is angle ABC, that is equals to 60 degrees in its size. So actually, this is the right triangle AOB that I copied from the original drawing. In this right triangle AOB, sinus 60 degrees equals to AO over AB. So write it down. Sinus 60 degrees is equal to AO over AB. AO is H over AB. AB is 5 according to what is given in the question. So in total, we should all know that sinus 60 degrees equals to H over 5. Sinus 60 degrees is square root of 3 over 2. So we substitute sinus 60 degrees by square root of 3 over 2. So in total, we should find out that square root of 3 over 2 equals to H over 5. Here we will multiply this equation by 5. And here that H equals to 5 times square root of 3 over 2. So we found out that the height H to the base CB of the right of the triangle ABC, the green triangle ABC, that is we are looking for the green triangle ABC. We know that the height to the base CB is H, and H equals to 5 times square root of 3 over 2 units in its length. Now it is very easy to find out the area of this grand triangle ABC. That is the area that we are looking for in this question. The area of this triangle ABC, the green triangle ABC, is equal to the base CB times the height to the base CB, that is actually edge, because it's right 90 degrees with the base CB, over 2. And again, the area of this green triangle, triangle ABC, is equals to the base CB times the height edge over 2. And again, the area that we're looking for this question, that is the area of the green triangle ABC, it is equals to the base CB times the height edge over 2. We have already found out that CB equals to 3 units in its length. Here, CB equals to 3 units in its length. CB equals to 3 units in its length times the height edge. We just right now found out that the height edge of this green triangle ABC is equal to 5 times 4 to 3 over 2. 5 times 4 to 3 over 2, and we have to divide it by 2. Okay, this is the base times the height over 2. So we have to divide the base times the height by 2. Again, it is the base that is 3 times the height that is 5 times 4 to 3 over 2, the height edge, and we have to divide it by 2. So in total, if you found out that the area of the green triangle, triangle ABC, it is equals to 3 times 5 is 15. So in total, in the numerator of this expression, we have 15 times 4 to 3. In the numerator, we have 2 times 2, that is 4. So in total, we found out that the area that we are looking for this question is equals to, that is the area of this green triangle, triangle ABC, it is equals to either 15 times 4 to 3 over 4 square units in its size. Or in terms of numbers, the value of this expression, 15 times 4 to 3 over 4, is equals to 6.5 square units in itself. So verify that not wrong. 5. It's exactly 6.5 units, 6.5 square units in its size. But again, we should find out that the area of this triangle ABC, that is the area that we are looking for this question, it is equals to either 15 times 4 to 3 over 4 square units in its size. In terms of numbers, the area of this green triangle ABC is equal to 6.5 square units in its size. So in the next step, I will summarize the lecture. In this lecture, our task is to find out the area of this green triangle, triangle ABC. So in the drawing, we have quadrilateral AQPCB. This is the big quadrilateral AQPCB. You know that AQ equals to AO. We also know that this is angle QPC, that is equals to 60 degrees in size. This is angle PQC, that is the right angle. This is angle ABC, that is also equals to 60 degrees in size. We also know that AB equals to 5 units in its length, PC equals to 4 units in its length. Again, our task is to find out the area of this green triangle, triangle ABC. So first of all, we did a construction. That is to say, from the vertex A, we draw perpendicular on QC. Again, from the vertex A, we draw perpendicular on QC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and QC. This point is point N. Actually, triangle AQC is an associated triangle. Why triangle AQC is an associated triangle? Because side AQ equals to side AC. QC is the base of the associated triangle, triangle AQC. And we have the rule that states that the perpendicular to the base of an associated triangle bisects the base. Again, the perpendicular to the base of an associated triangle bisects the base. So the perpendicular AM to the base QC bisect base QC. That is to say, divides the base QC into two halves. The first half is QM, the second half is MC, and each half of course equals to QC over 2. Again, the first half is QM, the second half is MC, and each half of course equals to QC over 2. So if we define the length of the first half QMSA, then the length of the second half MC must be also equal to A because they are equal to each other. In the next step, we extended the perpendicular AM by straight line until it touches side PC. We define the touching point of the extended perpendicular AM with side PC. This point is point N. Okay, so in the right triangle PQC, 90 degrees plus 60 degrees, it is 150 degrees. So this third missing angle must be equal to 30 degrees in size, because 150 degrees plus 30 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. AM is a perpendicular, it is absolutely a straight line. So when we extended the straight line AM by straight line, the result is AN. When you extend a straight line by a straight line, but the result must be also a straight line. Therefore, AN is a straight line. So if we focus on the right side of the straight line AN at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the right side of AN at point M? We have this angle that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So in the small right triangle NMC, we have here this angle is right angle. We have already found out that this angle equals to 30 degrees, so 90 degrees plus 30 degrees, it is 120 degrees. Therefore, this third missing angle must be equal to 60 degrees in its size. Why? Because 120 degrees plus 60 degrees is 180 degrees, that is the sum of the angles in any triangle. Therefore, this missing angle must be equal to 60 degrees in its size. It is very easy to see that the big right triangle PQC is similar to the small right triangle MNC. Why? Because this is angle C, that is a common angle that belongs to both triangles. Likewise, those two angles are both equal to 60 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees and therefore they are equal to each other. So if you found out that all the three angles of the big right triangle PQC are correspondingly equal to all the three angles of the right small triangle NMC. And therefore, those two right triangles are similar to each other according to angle similarity rule. So repeat again, if you found out that the big right triangle QPC is similar, this is the sign of similar, to the right small triangle NMC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side MC of the right small triangle NMC, or side QC of the big right triangle PQC, it is equal to side NC of the small right triangle NMC, or side PC of the big right triangle QPC. Again, we derive that side MC of the small right triangle NMC, or side QC of the big right triangle QPC is equal to side NC of the small right triangle MNC over side PC of the big right triangle QPC. MC is A over QC. QC in total equals to A plus A, that is 2A, and it is equals to NC. NC is the missing side, so units it is, over PC. PC equals to 4 units in its length according to what is given as the question. So in total, we should know that A over 2A equals to NC over 4. We have A in the numerator and A in the denominator, so A will get cancelled. So here we left only with 1/2, that equals to NC over 4. Here we cross multiply this equation and finally found out that 4 equals to 2 times NC. 4 equals to 2 times NC. Here we divided this equation by 2 and finally found out that NC equals to 4 over 2, that is 2. So NC equals to 2 units in its length. This is side NC that is equal to 2 units in its length. In the next step, I copied the big triangle A and B in a new page and analyze this big triangle A and B. So here, this is the big triangle A and B that are going from the original drawing. AB equals to 5 units in its length according to what is given as the equation. Angle A and B is equals to 60 degrees in its side. Angle ABN also equals to 60 degrees in its side. Actually, it is we already found out that angle A and B equals to 60 degrees inside, and angle ABC is equal to 60 degrees in its side according to what is given as the question. 60 degrees plus 60 degrees, it is 120 degrees, and therefore this first missing angle must be equal to 60 degrees in its size, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. 120 degrees plus 60 degrees, it is 180 degrees, that is the sum of the angles in any triangle. So if you found out that triangle A and B is an equilateral triangle, because all of its angles are equal to each other. And we know that in any equilateral triangle, all the sides are equal to each other, so AB equals to BN equals to NA equals to 5, because AB equals to 5. So here in the, we actually found out that NB in total equals to 5 units in its length. We already found out that NC equals to 2. So CB, the missing side CB equals to NB minus NC. Again, CB equals to NB minus NC. So CB equals to NB, that is 5. This is one side of the associated triangle NB. Minus NC, that is 2. So in total, CB equals to 5 minus 2, that is 3. This is the missing side CB, this is equals to 3 units in its length. Our task is to find out the area of this green triangle ABC. In order to find out the area of this green triangle ABC, we have to find out the height of this green triangle ABC. So from point A, we go perpendicular on the base CB. Again, from point A, we go perpendicular on the base BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and CB, this side CB, this point is point O. In the next step, I copied the right triangle AOB in a new page, and we analyze this right triangle A and B. AOB. So actually, this is the right triangle AOB that I copied from the original drawing. This triangle AOB equals sine of 60 degrees equals to AO over AB. Again, sine of 60 degrees equals to AO over OB. AO is edge, and AB is 5. So in total, sine of 60 degrees equals to edge over 5. Again, sine of 60 degrees equals to edge over 5. We know that sine of 60 degrees is square root of 3 over 2. So we substitute sine of 60 degrees by square root of 3 over 2. So square root of 3 over 2 equals to edge over 5. Here we multiply the equation by 5 and found out that the height edge of the green triangle ABC is equal to 5 times square root of 3 over 2. This is the height edge to the base CB, that is equals to 5 times square root of 3 over 2 in its length. Now it is very easy to find out the area of this green triangle ABC. The area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of this green triangle ABC must be equal to the base CB times the height to the base CB, that is edge, over 2. So the area of this green triangle ABC is equals to the base CB times the height edge over 2. And again, the area of the green triangle ABC equals to the base CB times the height to the base. That is edge. Why the height is edge? Because it creates 90 degrees with the base. So it is the height CB times the height to the base edge times the height to the base edge over 2. CB is 3. Edge, we just right now found out that edge equals to 5 times square root of 3 over 2. And we have to divide it by 2. So here we have 2. Again, because we have to divide this expression by 2. So we found out that we are looking for this question that is there of the green triangle ABC. It is equals to, in the numerator we have 3 times 5, that is 15, times square root of 3, over 2 times 2 is 4. So in total we found out the area of this green triangle ABC, it is equals to either 15 times square root of 3 over 4 square units in inside, so in terms of numbers, they have this green triangle ABC. Actually, the value of this expression is 6.5. So we found out that the area of this green triangle ABC, it is equals to either 15 times square root of 3 over 4 square units in inside, so in terms of numbers, the area of this green triangle ABC, it is equal to 6.5 square units in its size. Okay, thank you very much.